Welcome to another Q&A. This one is about radial reel, right? So this is radial reel here. It's a really nice reel, actually. Stainless steel, aluminum, aluminium, depending on where you are in the world. And we've released it because we recognize a whole lot of things where it's applicable. So let's try and go through those in a chronological order or some sort of syntax here. Our objective as window cleaners is to get half a gallon a minute or 2 liters a minute at the brush at 4, 5, or 6 stories. Now, you don't need to clean that high for that, but that's our target and our objective. In order to do that, we have to take a flow rate from somewhere and we have to deliver it at least at that half gallon a minute. If it's more than half gallon a minute, you can wind it down, right? But if it's less than half a gallon a minute, you can't wind it up. So when we go from the beginning of the system to the end of the system, we have source water. We might use DI tanks for the demineralization, so they don't take any pressure or flow rate out that's of any consequence. But if we have a reverse osmosis DI system, then we're going to lose some of the water pressure and some of the flow rate because half the water goes to waste, half the water is permeate or pure water, so that's what's going to go through to your pole. So now we have a couple of issues. We either run the pure water system on demand. If we run the pure water system on demand, then we're going to run it through some hose, run it through some tube, up a pole, and then clean some windows. If we do that, we're dealing with the head of gravity, which is back pressure, and we're dealing with what's called wall friction, which is the cumulative effect of the wall of the tube, creating a cumulative amount of resistance. The longer that hose or tube is, the greater the resistance. Now, what happens is that the bigger the inside diameter of a hose or tube, the less effect the wall resistance is on the flow rate of the water going through the hose. So as we have 26 jets in all of our brushes, we want to actually have quite a lot of water, which we talk about that half gallon a minute, 2 liters a minute. We talk about that. And so then we start reverse engineering, going all the way back and saying, well, what's stealing the flow rate, right? What's causing back pressure? What is the resistance that we're dealing with? And how do we eliminate those? So one of the things we did with Flow Red, for example, is we changed the design of Flow Red so that it went from it was a clever system, and we didn't need it to not be clever. But in making it clever, we were losing half gallon a minute inside the Flow Red. So Flow Red Plus was designed to get that half gallon a minute back, right? Just normally through Flow Red. Then we changed from, or around the same time, we changed from Rhino tube, which was a 5/16 inch outside diameter tube, to High Flow, which is a 3/8 inch outside diameter tube. Sorry, I grew up with metric, so I have to think about the imperial measurements for the American market. But basically, we went from an 8mm tube to a 10mm tube to get the inside diameter of that tube bigger, so we get less resistance. Then the maximum length of 10mm 3/8 tube that you should run without that cumulative effect of the wall friction, making a significant effect on the flow rate possible at the brush, is about 150 feet. So then we go and say, okay, we've got 150 feet, but a lot of window cleaners want 300 feet, right? We give you 75 feet of high flow with an elite pack or any pole. So we need another 225 feet for somebody to be able to go 300 feet or 100 meters, yeah? And that would have been fine, except that the standard hose available in the United States is 5/8 of an inch. 5/8 of an inch, yeah. 19 millimeters, which is really big. It's like garden hose in America is really, really big. So, and it's unnecessarily big, right? So okay, you're not gonna have very much wall friction from that size hose, but we only want half a gallon a minute at the other end. So what we did is we came up with Radial Hose, which is the green hose here. That is 5/8 of an inch OD, not 5/8 of an inch ID, right? Which is a garden hose in America, right? So, and it's all scientifically calculated. I'm not going to go through the calculations with you in this video, but it's scientifically calculated that we have the highest flow rate, the least amount of wall friction, the least amount of resistance in order to deliver the water to the high flow tube, in order to deliver the water to the brush, such that we can get a half gallon a minute with a standard flow rate available at the tap or after an RODI system. Yeah. So once you want to carry 225 through to 300 feet of hose and tube, yeah, you pretty much got to get a reel. Yeah. So we made radial reel, and it's super cool, and it'll carry all the hose and tube. It carries 300 feet, 160 feet of hose and 150 feet of tube. And what do we want to say about that?
The inside where the tube attaches?
Oh, yeah, so there's some little tweaks, right? It's stainless steel construction with a little bit of aluminium, like this piece here is aluminium. But the reel itself is stainless steel.
You want to pull it out?
No. No, I don't think so. But it comes with these brackets. You can see them at the back. That brackets, you can either wall mount it in your vehicle, or you can floor mount it. You can mount it so it doesn't pull out from wherever you want to locate it. And you can carry it if you want to actually carry it and make it mobile, right? Really easily. You just undo these, right? And then once they're off, you can just pull it off real easy. Yeah. So on the other thing, which I know from when I was a window cleaner, is that, in fact, it was on Facebook the other day where a guy said, I've lost my water pressure and I don't know what it is. And people were talking about the inside of the reel being blocked and all that. But there's probably a 90% chance that what happens when the water comes into the reel, it comes in and then it winds onto the core, right, of the reel. And it's that wind-on point where it goes over an edge. And over time, when you wind the reel on and off, the hose on and off, you can crimp the hose at that point where it goes over the edge and onto the reel to be wound onto the reel. So what we've done on the inside, way down deep in there, is we've got a stainless steel casing over the hose. It's a flexible casing, right? So it goes over the hose and until the hose is on the reel, so it can be wound onto the reel. And that means that you'll never have that crimp. I remember when it happened to me, and you can't easily see that it's crimped. But if you cut the hose and refit it, then you realize that it was crimped, right? So this way, that the inside piece of the hose will never crimp, and so you get a really long life experience with a radial reel. What else do we want to say about it, Martin?
Well, I think you talked about how you can mount it on the floor, how you can mount it on the wall. You can just unscrew these on the top so that it's really easy.
Yep.
And then...
we could talk about this piece here.
Yes.
So the join from the hose to the tube...
From the radial hose to the high flow tube.
Yep, thank you. Is a push fit. So it doesn't take up a lot of bulk. And then we put collar locks or locking clips on each of these points here, so that if you're pulling it along the ground and you hit a curb or a rock or a piece of playground or something like that, it doesn't pull the collar back and release the hose and tube. And then of course you can use a 10-10 straight push fit to connect this high flow tube to your high flow tube if you want to use another 75 feet of high flow tube, right? Traditionally, in the terms of fluid dynamics, you should fully deploy hose off a reel when you're using it to maximize your flow rate. But as long as you're getting half a gallon a minute, that would only be relevant information to you if you're actually struggling for flow rate. And then there is a second friction. Water wants to go straight in a straight direction. It flows in a linear sense. So when you're making it go round and round and round and round and round, you're actually pushing it against one of the walls, the outside wall, on a continual basis, and you're kind of pushing, and the wall friction is greater in a circumferential sense than it is when it's in a straight line. So if you're ever a little bit short, then you can just fully deploy all the hose and tube, and you'll just get a little bit more flow rate.
And I made a video of that, how you pull it out. So maybe we can watch that.
Yeah, let's drop a little video in here. You can buy Radial Reel fully loaded. You can buy Radial Reel on its own if you're happy with the hose and tubes that you've got. And if you love the idea of the Radial Hose and you've already got a reel, you can also buy that. It's all in the store under Radial Reel, Radial Hose, and High Flow. Yeah. And if you want just the hose, you would click no reel, no high flow. If you want just the reel, you'd click yes to the reel, no to the hose, no to the high flow. Like
yes.
That. So that's where it is in
it's on the front page now, so just scroll down a little bit, you find it. And if you watch this video later, you can just search Radial Reel and you will find it immediately.
Yeah, and this video is being filmed in March 2022. So we actually had the first shipment actually leaves here on the 23rd of March, so maybe next Monday or Tuesday. Yeah. And so that'll be available for delivery in April, and then we've just bought another 100 plus reels, and so we will dispatch them in about maybe 10 days from now. And then so then next batch, like they've actually sold really, really well, the first batch. So so it may be middle of April, end of April delivery if you are not fast, or if you watch this video after April, then I think we'll be fully stocked in the US with them. So it'll be a fast delivery, okay? See you in the next Q&A.